This is Dr. A.T. Now today we are going to explain solve d square plus 4 of y equals to x sine x. This is also second into higher order differential equation. Actually, this problem solved out the solution means using operator form. The problem here already given operator form. Here d is the operator. First of all, write the given problem d square plus 4 of y equals to x sine x. This is the given problem. Actually, the solution means here find out y equals to complementary function cf and particular integral pi. In which differential equation RHS is there, the value, find out the particular integral, or otherwise only find out the CF complementary function. Okay, here both functions find out in this given problem, complementary function and particular integral. Okay, first of all find out CF. Here consider the auxiliary equation a equals to 0, that implies f of m equals to 0. The given equation in terms of m, I mean f of d, here write in terms of m. Here first of all assume that let f of d equals to d square plus 4. In this f of d, here write in terms of m, that is m square plus 4 equals to 0. Find out the complementary function means here find out the roots of m, that is m square equals to minus 4, m equals to plus or minus 2i. Using the formula alpha plus or minus I beta, that is 0 in this given roots of m, 0 plus or minus 2i. Okay, here alpha equals to 0 and beta equals to plus or minus 2i. In this type of roots, I mean alpha plus or minus I beta, then the complementary function CF equals to e power alpha x c1 cos beta x plus c2 plus or minus c2 sine beta x. Okay, here write e power alpha means 0x, c1 cos beta x means c1 cos 2x plus or minus c2 sine 2x. Here beta means 2. Next, that e power 0x means 1, that is c1 cos 2x plus or minus c2 sine 2x. This is the complementary function CF. Okay, now find out the particular integral pi. Pi equals to formula means 1 by f of d into q of x. Here f of d means 1 by d square plus 4, d square plus 4 into q of x means in the given RHS, that is x sin x. X sin x. Okay, here find out the particular integral means the case number means 4, that is x power n into v. Okay, here n means 1, v means sin x, that is x power 1 into sin x, that is x sin x. First of all, here sin x means sin ax. Sin ax means here write imaginary part of imaginary part of IAX. Here A means 1, that is IX, imaginary part of IX, 1 by d square plus 4 into x. Here into x, x power n or x power k. This is third case of pi. First of all, substitute ix in place of t and applying the particular integral case x power n or x power k. First of all, substitute in place of d means ix. So next that here imaginary part of e power ix 1 by, here in place of d substitute ix. Here x power n into v, e power ix means in place of d substitute d plus ix, that is d plus ix whole square plus 4 into x. Next that imaginary part of e power ix 1 by d square plus I square x square, that is minus x square, I mean a square plus b square plus 2ab 2dix plus 2dix plus 4 into x. D square plus, in place of d, here substitute only d plus a, not there x here, here I square means minus 1. Here in place of d only substitute d plus I. Here d plus I whole square plus 4, d square a square plus b square, that is I square minus 1 plus 2ab, that is 2di plus 4 into x. Next of all imaginary part of e power ix by d square plus 2di plus 3, 4 minus 1 3 into x. Now applying case 3, particular integral case 3 in this f of t, here constant will taken out the common here. Why? Because applying case 3 particular integral in the denominator of f of d, the form of 1 plus or minus f of d, so that here taken out the constant 3 common here, that equals to imaginary part of e power ix 1 by 3 into 1 plus d square plus 2di by 3 into x. Next of all, that equals to imaginary part of 1 by 3 into 1 plus d square plus 2d by 3 whole power minus 1 into x, 1 plus x whole power minus 1. Applying the formulae here, that equals to imaginary part of 1 by 3 into 1 plus d whole power minus 1. Here in place of d is that d square plus 2d by 3. 1 minus d, that is d square plus 2d by 3 plus d square, that is d square plus 2d by 3 whole square plus minus so on. Here the expanding 1 plus x whole power minus 1 using binomial theorem here. X into 1 means x minus d square by 3, 2 times differentiation of x, that is 0, 2d by 3. 2d by 3 means here 2di, this is 2di, here also 2di. Okay, now the expansion of d square by 3, 2 times different expansion using here binomial expansion 1 plus d square plus 2d by 3 whole power minus 1. Here in place of d is there d square plus 2di by 3. Okay, here Next, the 2d I by 3 into x, one time differentiation of x, that is 2I by 3. Next, that whole will get 0 here, only x is there. These are all 2 times differentiation, then we'll get 0 here, so that enough this x minus 2I by 3. That equals to imaginary part of 1 by 3 into x minus 2I by 3. This is the particular integral. Therefore, the solution y equals to CF plus PI. That is, here C1 cos 2x plus or minus C2 sin 2x plus 1 by 3 plus 1 by 3 into x minus 2I by 3. Here, e power ix is there. E power ix, imaginary part of e power ix. Imaginary part of e power ix also is there. Okay, here e power ix is there. Next, that c1 cos 2x plus or minus c2 sin 2x plus 1 by 3 into e power ix means, right, cos x plus I sin x into x minus 2I by 3. This is the solution of the given problem. C1 cos 2x plus C2 sin 2x plus 1 by 3 cos x plus I sin x into x minus 2I by 3. This is the solution of the given problem. Okay, thank you.